Graphing attributes notes. So we are going to actually use the 5.10 notes that we took before to address this, and I was going to go over them separately here for you, but you will refer back to your 5.10 notes that look like this. I'm going to click on it for y'all. So these 5.10 notes, we're going to finish the others on it. Okay. So quadratic attributes. So we've been talking about attributes like the axis of symmetry, the solutions, the domain, the range. So what I'm asking you guys to do, you're going to have two problems to work. I want you to graph your quadratic. I want you to label the AOS, which is axis of symmetry. I want you to circle the solutions on the graph, and that's where it crosses the x-axis, and square a set of reflection points. Now, reflection points are going to be 2 points that are on opposite sides of the axis of symmetry that reflect upon each other. So when you look here, you see that this one is an exact reflection, just like we talked about with symmetry, of course, of this point right here. Those are my reflection points. Solutions are also a set of reflection points. So technically they can have a circle and a square, but they're the exact same distance from the axis of symmetry, okay? After that, you will fill in the boxes at the bottom of your pennant, and then you're going to decorate it. Okay, so let's go down here. And example number 4 is to find the zeros of 2x squared minus 2. Hopefully you recall that zeros is another word for x-intercepts. So I'm going to bring up my calculator. I'm going to go to y equals, and I'm going to clear the equation in here. And I'm going to graph it. So I'm going to go to y equals. I'm going to do 2x, make sure you use this as your key, squared minus 2. Now, I don't want to just look at the graph because I need to get the specific points. You never just sketch what you see on the screen, okay? So I'm going to go to second table, and I'm going to look for the Oreo in the y value, and we explored this with 510. I'm going to look for where that pattern repeats itself, and I see it right here in between -2 and 2. I see the 6, so the top of the cookie, bottom, cream center, bottom of, plain side of the cookie, and then the printed side is basically how it is. So there is my Oreo between -2 and 2, which I happen to give you on here, but for the pennant, you're going to have to do it yourself. I'm going to show you a couple of examples on that. You always want to look for that Oreo, and that's what you're going to write down, what'll fit on the graph. So -2 produces a 6. -1 produces a 0. 0 produces a -2. And then 0 and 6. Okay, I happen to know that these are my solutions, my roots, or on this one, it asks for my zeros. Okay, I'm then going to plot them. As a reminder, a point is x, comma, y, gives it to you right here. Looky there. Okay, so I'm going to go to -2, 6. I don't know why it does that. 0, -2, which is right down here. Okay. 1, 0 right there, and then 2, 6. So what happens is when I see that I've hit my vertex and I'm going back up, then I realize I can just do a reflection point. This is the center. This one's 2 over, so this one would be 2 over. It's a reflection. Okay, and then remember, even though it's hard on ones like these, this is actually going to be a U shape as best you can. Okay, arrows at the top because it goes on forever. Okay. So then what I'm going to do, and what I'm asking you guys to do today, is I'm going to label my axis of symmetry, which is the line down the middle. So my AOS is x equals 0. It's a straight vertical line at x equals 0. Then I'm going to circle my solutions, okay? I'm going to circle my solutions, which is where it crosses the x-axis right there. And this one has to be x equals 1 and x equals -1. I am then going to square a set of reflection points. So these reflect to these, and sometimes you'll have more or less, but I'm just asking you to do 1. So these are your reflection points like I'm asking for. Okay. Now, on the pennants, it might ask you to label your points for your solutions. So to give the solutions as a point, this would be 1, 0 and -1, 0. All right, the other thing it might ask for is the vertex. The vertex is the point where it changes direction, and on this one, it's right here. So on this one, my vertex would be 0, -2. And on this one, it is a lowest point. It's the lowest point on the graph, so it would be a minimum. So that is the information you're going to have to do on your pennant today. This is practice for our major grade over this, so I just wanted to go over these with you, and we had these two examples to still do. I'm going to come over to the right, and I'm going to go on ahead and address domain and range, okay? Domain is all my x values, range is all my y values. So lots of information for each problem. That's the reason I'm not asking y'all to do a whole lot. All right, domain is all my x values. And as I told y'all, it's always -infinity to positive infinity. And it's a less than sign because we cannot contain infinity. And we also call this all real numbers, which is what was on your assignment. The range values, you always go from smallest to largest or bottom to top in this instance. And my lowest point is right here, which we already discussed, which is -2. My minimum value is -2, and it goes up and on forever. Positive forever is to infinity and beyond. It is my y value. This one is less than, but this one is less than equal to because this is a solid dot down here. It does include that -2. So when I rewrite it with the y on front, it's eating the y, so y is greater than or equal to -2, which makes sense. All my y values are above -2. So lots of information there. Next problem, number 5, okay? So on number 5, it's already set equal to 0, so I now need to graph it. I'm going to pull up my graphing calculator. I'm going to go to y equals, and I'm going to clear because it'll sometimes insert, not just type over. You need to enter that first one as a -x². If it's the first thing, you enter it as a negative. If it's in the problem, you enter it as a minus. So here's my equation. So now I'm going to go to the table by hitting second graph, and I'm going to look at the table. And oh, all right, the Oreo is right here. I see it. -7, -2, 1. There's my cream center, and then you start on the other side of the cookie. So there is my Oreo of numbers. So I'm going to now write those down. Back to my color coding. -3 produces a -7, -2, 1, 2, and then it repeats in reverse order. It's like a mirror reflection of each other, just like the axis of symmetry. I don't happen to see where y equals 0, so that's kind of questioning, but that's okay. I'm going to start graphing. A point is x comma y. Okay, so I have -3, -7. I have -2, -2. I have -1, 1. I have 0, 2. I have 1, 1. I have 2, -2, and 3, -7. So I can actually see that reflection across. This one actually has the same axis of symmetry. I'm going to draw a U shape. No, it's got to be a smooth curve at that U right there. Okay, beautiful. So the first thing I'm going to do is identify my axis of symmetry because that's the easiest to me. It's the line down the middle, which is right here. So my AOS is x equals 0. My vertex is right here. So my vertex is 0, 2. That's the point where the graph changes direction. It also shows me what my either maximum or minimum value is. On this one, it tends to be a maximum. It's the highest point. And then I have to circle. So I have to circle my solutions. Okay, this is weird because my solution is here and my solution is here. It's not exact, but we have discussed that several times. And it's okay for you to write between -1 and -2. And then this one is between 1 and 2. And that's completely appropriate. You just as long as you circle and see, it doesn't always have to be exact. Now I need to square some reflection points. So I have several reflection points. I have a set here and I have a set here. So there's my reflection points. Okay. That covers the information that it asks on our page. It asks for either the vertex or the solutions. I do want to again address domain and range, even though there's a line on the bottom. This fits better on my screen, so y'all can write it on your line. Again, I told y'all that the domain is always all real numbers. It's going to go from -infinity to positive infinity. This arrow is going to go left forever, and this arrow is going to go right forever. Now my range, oh, sorry, let me finish that infinity thought. This is always less than because you cannot equal infinity. Buzz Lightyear, been looking for 26 years. I know I use that joke all day. I'm gonna keep using it. Now the range value is on my y values, and I always start at the lowest value. Well, the lowest value is this arrow that goes on forever, and negative forever is negative infinity. And it goes all the way up to your highest point, and your highest point is right here, which just happens to be 2, always reflected in our vertex, okay? So, excuse me, that's our y values. It's less than or equal to 2, and it's just less than infinity. So what this is saying is y is greater than negative infinity, but it's less than or equal to 2. And this is what it'll be if it's just the single term solution. The other thing I did want to point out is your vertex just happens to be your maximum value here. It is the highest value, okay? So it's the biggest number. That's it. When you guys go to the penance, just make sure you answer all the questions. And that is it for today. Thanks.